Okay, in this videotape, we were going to again look at addition and subtraction of fractions, but this time we'll be handling some more complicated examples. I just want to go over what you already know. In order to add two fractions, they have to have the same denominator. If you have two fractions with the same denominator, a over c plus b over c, what you do is you add up the numerators and place it over the common denominator. So a over c plus b over c is a plus b over c. And this is also good for subtracting fractions. If they have the same denominator, and that's a very important if, they have the same denominator, you subtract the numerators and place them over the common denominator. And this is applicable if you have more than two fractions. For example, 7/9 plus 2/9 minus 4/9, they all have the same denominator, so you simply combine the numerators, 7 plus 2 minus 4, place them over the common denominator, and then simplify. So you get 7 plus 2, 9 minus 4, 5/9. Okay, now the next question is what happens if you want to work with fractions, add or subtract them, and they do not have the same denominator? For example, 3/4 minus 1/6. Okay, the trick here is to build fractions that are equivalent to these fractions, but which do have the same denominator. And once you do that, you combine using these rules here. Okay, now the way we're going to build fractions equivalent to these fractions is to use the fundamental principle of fractions. You've seen this in earlier videotapes. Just want to go over it with you. That if you have a fraction, a over b, it's perfectly okay to multiply the numerator and denominator by the same non-zero quantity. In this case, k. Okay, you will get an equivalent fraction. Okay, this can be used. Now, this rule can be used either way. If you have a fraction, you can divide numerator and denominator by the same non-zero quantity, k, and get an equivalent fraction. In this particular videotape, we'll be using the rule in this form. In other words, taking a fraction and building a fraction equivalent to it, but which has a denominator that we desire. Okay, now the question here is, what denominator should we build what should be the denominator in the fractions that we're building? Now, we want it to be a denominator. Okay, a number so that 4 and 6 both evenly divide that number. Okay, we are looking now, in a pinch you could use the product of the denominators, 4 times 6, 24. But it's more efficient to find what we call the least common denominator, the smallest number, so that 4 and 6 evenly divide it. Okay, and there's a little trick involved in finding the least common denominator. We discussed it in an earlier tape on addition and subtraction of fractions. The idea is to factor each denominator completely. Okay, if we're talking about numbers, then we're just going to take it down to their prime factors. 4 is 2 times 2. 6 is 2 times 3. And the least common denominator is obtained by taking each factor the greatest number of times it appears in any one denominator. In this particular example, we only have 2's and 3's. 2 appears twice. 2 appears once, so we use it twice. Not the total number of times it appears, but the greatest number of times it appears in any one denominator. Okay, so although we have a total here of 3, we only take it twice. It's twice here, once here, we take it twice. 3 is 0 times here, 1 time here, we take it once. This tells me that 2 times 2 times 3, or 12, is the least common denominator in this problem. So what we're going to do is build fractions equivalent to these fractions, which have denominator 12. Okay? We would like to build fractions equivalent to these with a denominator 12. Now, what we have to do is remember that according to the fundamental principle of fractions, whatever we do to the numerator of the fraction, we have to also do to the denominator. So here we look, and to go from this denominator to this denominator, we multiplied by 3. We must also multiply the numerator by 3 as well. If the denominator is 4 times 3, the numerator is 3 times 3. Here, to go from this denominator to this, we multiply the denominator by 2, so we multiply the numerator by 2 as well. This is 9/12. Here we have 2/12. You do not reduce at this point. Don't make 2/12 1/6. You'll be going around in circles. We have it in the form we want it. We wanted two fractions having the same denominator so that we can use this rule over here, which says that if you want to add or subtract the fractions, they have the same denominator, you combine the numerators. Okay? over the common denominator. So we have 9/12 minus 2/12, same denominator. We combine the numerators, 9 minus 2 over 12, and we get 7/12 for our answer. Okay, if you can't find the least common denominator, it's not catastrophic. You can, in a pinch, use the product of the denominators. Okay, but this can cause some problems in reducing to simplest form at the end. Okay, so try to find the least common denominator. Okay, now let's try looking at some fractions with variables as well as constants in them. We're going to look at algebraic fractions. Let's say we want to add the fractions 4 over 3x squared plus 5 over 2x squared minus 6x. We're going to mimic the procedure that we used before. We're going to take each denominator and factor it completely. Well, 3x squared is simply 3 times x times x. Okay, constants you write as a product of primes. 3 is already a prime here, and x squared is x times x. Down here, we can factor out a 2x, giving us 2x times x minus 3. This is 2x squared minus 6x, checking our answer by the distributive law. Okay, so we have everything factored. This is 2 times x minus 3, 3 times x times x. The LCD is found by taking each factor the greatest number of times it appears in any one denominator. 3 is here once, here no times, we take it once. 2 is no times, 1 time, so we take it once. X is here twice, here once, so we take it twice. And finally, x minus 3 is not here, but it's here once, so we take x minus 3. And the LCD is 3 times 2, 6x squared times x minus 3. Okay, having found the LCD, we're going to proceed as we did in the example with the 3/4 minus 1/6. Once we determined the LCD was 12, we built fractions equivalent to these fractions that had the denominator 12. The same thing here. We're going to build fractions equivalent to these fractions that have the denominator, in this case 6x squared times x minus 3. Okay. Let's rewrite the problem. 4 over 3x squared plus 5 over 2x squared minus 6x. I'll write that as 2x times x minus 3, so we can see exactly what we're dealing with. Now, I want to build fractions equivalent to these, having the denominator, which is the LCD, 6x squared times x minus 3. Okay, and what we're going to do is ask ourselves, in each case, what did we multiply the denominator by to get the new denominator, and whatever that was, we multiply the numerator by the same quantity. The original numerator is going to be multiplied by something here and here as well. Okay, and we look to go from this denominator to this one. Well, to go from 3x squared to 6x squared, we multiplied by 2. And to get the x minus 3, we had to then multiply by x minus 3 as well. Okay, to get from here to here, we had to multiply by 2 to give us the 6. X squared we left alone, and then by x minus 3. So that's what we multiplied the denominator by. We have to multiply the numerator by it as well. Now let's look in this example. To go from 2 to 6, we multiplied by 3. To go from x to x squared, we multiplied by x. We had x minus 3, so we didn't have to do anything there. So we multiply the denominator here by 3x. To get this, we multiply the numerator by 3x as well. Let's see what we have. This is 8 times x minus 3 over 6x squared times x minus 3. And this is 5 times 3x, 15x over 6x squared times x minus 3. Of course, you do not cancel the x minus 3's here. The whole idea is that we now have fractions with the same denominator, and we can add up their numerators and put it over the common denominator. Okay, let's see what we have. Just rewrite it. We have 8 times x minus 3, now plus 15x all over the common denominator, 6x squared times x minus 3. Two fractions with the same denominator. We add up their numerators. We put it over the common denominator. Okay, now let's simplify the numerator as much as possible. We can distribute the 8 through the parentheses. We get 8 times x minus 8 times 3, 8x minus 24, plus 15x over 6x squared times x minus 3. Okay, 8x and 15x are like terms. Okay, we can combine them. We get 23x minus 24 over 6x squared times x minus 3. And this is our final answer. Okay, before we do some more complicated examples like this, I just want to show you an example, two fractions that have the same denominator. Okay, but you have to still be careful. 2x minus 7 here over 2x plus 4. Okay, we want to subtract these fractions. They have the same denominator. So what we do is we combine the numerators over the denominator. Now you have to be careful here. You'll need parentheses because the second fraction here has more than one term in the numerator. Okay, so when you're subtracting, it has to be done like this. The 2x minus 7 has to be in parentheses. Okay, you're going to subtract the numerators and put them over the common denominator. When it was, say, 7/9 minus 2/9, you didn't have much to worry about. 7 minus 2 just gives you 5/9. But here it is a subtraction, and when you're going to be subtracting these two terms, okay, don't forget to put them in parentheses. There's really like a minus 1 here that has to be distributed through the parentheses. This gives us 3x minus 5 minus 1 times 2x minus 2x plus 7 all over 2x plus 4. And we can combine, and we get 3x minus 2x, that's x. Combining like terms, minus 5 plus 7, that's plus 2, all over 2x plus 4. 3x minus 2x gave us the x. Minus 5 plus 7 gives us a plus 2. Okay, and we're not quite finished because we would like our answers always to be in lowest terms. That is, we do not want the numerator and the denominator to have any factors in common. So you factor completely. The x plus 2 is okay, but in the denominator we can pull out a 2, leaving us with another x plus 2 there. And we can, using the fundamental principle of fractions the other way, divide numerator and denominator by x plus 2 and reduce this to lowest terms. Divide x plus 2 by x plus 2, you get 1. Divide x plus 2 by x plus 2, you get 1. So your final answer, half. Okay, so when you're adding and subtracting fractions, the whole key is to get the same denominator. And even if you have the same denominator, you still should be careful in a subtraction. If you're subtracting a fraction whose numerator has more than one term, make sure you use parentheses. Okay, let's try some more complicated examples. X plus 3x over x minus 2. Okay, we want to add fractions. We really do have fractions here. X is really x over 1. Now, the LCD in this case is very simple to find because this denominator is just 1. This is just x minus 2. Okay, so we need 1 times x minus 2, or just x minus 2 for the LCD. Taking each factor the greatest number of times it appears, we just get the product of denominators in this case. We're going to combine these fractions over the LCD of x minus 2. Okay, well, clearly the second fraction can be left alone. It already had a denominator x minus 2, so we didn't do anything to the denominator. We don't do anything to the numerator either. To go from this denominator to this one, we had to multiply the denominator by x minus 2. Therefore, we also multiply the numerator by x minus 2. This gives us, now we have two fractions with the same denominator. We combine the numerators and put them over the common denominator. This gives us x squared minus 2x, using the distributive law, sending the x through the parentheses. X squared minus 2x plus 3x over x minus 2, giving us x squared plus x over x minus 2. Okay, now you really have to be careful here to make sure that this answer is in lowest terms. Okay, if you remember back over here, we factored the denominator, and when we did that, we saw that it did have a factor in common, namely the x plus 2, and we could reduce. So here, you really would have to go, say, one more step in which you say x squared plus x is x times x plus 1. And then you see that, no, there are no factors in common. Okay? X squared plus x over x minus 2. Nothing else factors out. Nothing else cancels out. Okay, let's try one more example. X over x squared minus 3x plus 2. Take away 4 over x squared minus 2x. First job is to find the LCD, and we're going to have to factor these denominators completely. And then we'll be able to determine the LCD. Okay, here we have first of all, we see there's nothing that these three terms have in common that we can pull out in front. It's a trinomial with lead coefficient 1 here, and we can factor it by saying we know two numbers which multiply to plus 2 and add to minus 3, and they are minus 2 and minus 1. And of course, you should check to see if you factored it correctly by using FOIL. First, x squared, outer minus 1x, inner minus 2x for the minus 3x, and then last for the plus 2. You should always check your factoring. Okay, x squared minus 2x. Here we do have something in common. The two terms have an x in common. Gives us x times x minus 2. Now, to get the LCD, we take each factor the greatest number of times it appears in any one denominator. The first factor is x minus 2. Appears here once, so we take it once. Then we have x minus 1. Here once, here no time, so we take it once. And finally, x. Here no times, here one time, so we take it. Okay, now here, x minus 2 is the entire factor. X is not a factor. Okay, x is a term in this particular factor. Okay, so don't make the mistake of thinking, well, there are two x's here and 2 in here, and take it x squared or something like that. The factors I have, say, in parentheses, x, x minus 2, the whole thing, x minus 2, the whole thing, x minus 1, the whole thing. X is a term in this factor. It is not a factor here. Okay, now that we have it factored, we have the LCD, let us combine these fractions over the lowest common denominator. We'll rewrite the problem with the denominators factored. This is x over x minus 2 times x minus 1 minus 4 over x times x minus 2. Okay, now x times x minus 2 times x minus 1 is the LCD. So we want to build fractions equivalent to these that have the denominator x times x minus 2 times x minus 1. X times x minus 2 times x minus 1. Each case, we'll ask ourselves, what did we multiply this denominator by to get that one? And whatever it was, we'll multiply the numerator by the same quantity. Okay, we look here. To go from x minus 2 times x minus 1 to x minus 2, x minus 1, clearly we multiplied by x. We therefore multiply the numerator by x as well. To go from x times x minus 2 to x times x minus 2 times x minus 1, we've multiplied the denominator by x minus 1, so we must multiply the numerator by x minus 1 as well. Now we have two fractions with the same denominator. We combine numerators, put it over that denominator. X times x, or x squared, minus 4 times x minus 1, all over x times x minus 2 times x minus 1. To simplify, we will have to distribute the minus 4 through the parentheses here, giving us x squared minus 4x plus 4 over x times x minus 2 times x minus 1. X squared minus 4x, minus 4 times minus 1 plus 4 over this. Now, you're not quite finished until you factored the numerator, or at least tried to see if there are any factors in common in the numerator and denominator. If there are, you have to cancel them out. Okay, so we finish it up here. X squared minus 4x plus 4 is x minus 2 times x minus 2. We're looking for two numbers which multiply to plus 4 and add to minus 4. They're minus 2 and minus 2. Here we have x times x minus 2 times x minus 1. And we see that the x minus 2's cancel out. You divide numerator and denominator by x minus 2, giving us a final answer of x minus 2 over x times x minus 1. That brings us to the end of this problem and also to the end of the table.